Okay, so let's talk about the products for a second. Fertilizer, what it is and why we need it. Fertilizer application. Each year the world's farmers apply over 100 million tons of nitrogen, phosphorus, and potassium fertilizers. In the U.S., 97% of all acres planted to corn receive an application of nitrogen fertilizer. Fertilizer can be a major expense in production costs. So why do we add fertilizer? Reduce nutrient deficiencies. So what can a nutrient deficiency do to a crop? Corn with nutrient deficiency, example, would be to sustain the growth of the world without any growth in the amount of available farmland, we need to strive to push how much we can produce, which would be our yield, on each acre. Our crops require a vast amount of nutrients to produce its yield to its fullest potential. When a plant does not have enough of one particular nutrient, it would be deficient and result in a yield short of its potential, affecting the consumer because there was less of a crop produced, and affecting the producer because he's having less of a crop to sell. So we utilize precision agriculture to try to avoid these situations. What does precision agriculture have to do with fertilizer application? If implemented, a producer might see higher crop quality resulting from better matching of inputs to crop needs. Fertilizer would need to be applied where it is needed and not applied where it isn't. And over-application can reduce crop health as well as not applying enough. Fertilizer and environmental impacts. Nitrates that leach through the soil often end up in the groundwater, a major source of drinking water for those living in rural areas. Phosphorus gets into lakes and streams by clinging to soil particles, and high levels of nitrogen and phosphorus can harm aquatic life. Let's look at pesticides. Like fertilizer, pesticides need to be carefully applied and have numerous benefits of being applied in a variable rate format. Pesticides include herbicides which target plants, insects, and diseases. And just like fertilizer, the ability of being able to apply the right amount on a specific area gives the opportunity to apply something needed to a certain area or areas of the field and not being applying when traveling over areas where it is not needed, thus saving money and allowing the field as a whole to reach its fullest potential. Pesticides are greatly help boost yields in modern agriculture. The ability to keep a clean field free of weeds improves yields considerably. Anytime there is a weed, that weed is robbing nutrients, water, and sunlight from your crop. Insects. More is being discovered every day about how much yield is being lost from insects. Insects can attack a plant from both below ground and above ground. Very similar to insects is diseases. Diseases are able to affect roots or tissue. Both insects and diseases can be devastating. They can wipe out a crop just prior to harvest, leaving a grower with all those inputs already purchased and applied, with limiting the return. So any technology that will allow us to better use pesticides would be beneficial for both the grower and the consumer. So what is the scope of this and how far can or does it go? We talked about some examples of application, but it does not end there. I mentioned that the goal of precision farming is to be inserted into every pass every time. So what does that mean? Soil sampling. We will get into soil sampling in more detail in our chapter, a chapter that is all about soil sampling. But to introduce it here makes sense. I mentioned that we need data. If we are going to treat the variation in the soil with a scientific approach, and to do this, our data must come with consistency. So we use GPS to track our soil sampling locations and to log our data points or our location points so that the test results can be matched with each location. Tillage. Stepping back from the variable rate application, something as simple as tillage has been greatly changed with GPS. It started out with a light bar in the cab of the tractor where the operator could put in his implement width and steer towards the lights on the display, thus preventing overlap and improving efficiencies. For example, field work at night. Not all implements had a marker that would leave a mark to follow on the next pass, so night work was a difficult task. GPS saves that day. Or making an application when the wind is blowing, kicking up dust sometimes makes your last pass almost invisible. GPS saves the day. Planting. We already discussed variable rate applications such as plant varieties and populations, but GPS gives us the ability to shut off individual rows to prevent overlap, saving your real dollars and costs. Here's an example of a field broken down into management zones. These zones are used for soil sampling. Then the results can be entered in, and the correct amount of limestone, for example, would be variable rated as the application unit goes across them. The technology to be able to variable rate a pesticide application is not as widely adapted at the moment as fertilizer, and it brings with it unique challenges. Fertilizer applications are based off variations that change slowly over time, and pesticide applications change a little more quickly, so there are some challenges to be met on both the equipment side and the ability to gather data fast enough and put it into a usable format. But with some improvements that are coming online every day, it will become a more widely used application. Producers have always conducted field analysis, but the tools of GPS allow us to track it, and if a problem arises, be able to put it in a format that can include a treatment for a weed, insect, or disease. The pass of physically monitoring the field with GPS can help make advanced applications using the right product at the right place. Crop scouting via remote sensing is something that is new with precision agriculture, and let us monitor and look for certain issues remotely via aerial, satellite, or UAV imagery. This pass also lets us see a problem and tie a solution to the exact coordinates that the problem occupies. We will get into this more in chapters to come. Like soil sampling and remote sensing, yield monitoring will be a chapter all itself. But to get into it a little bit here, yield monitoring is used to track yield based on position in the field. Combines equipped with GPS and grain flow sensors can calculate yield per acre when harvesting. Yield data collected allows a producer to create yield maps. Yield map allow a producer to see where yield is high and where yield is low, and be able to make management decisions for what might need to be changed next year. This is the precision farming cycle. Everything that gets done in precision ag fits into one of these categories. It is tough to distinguish where in the cycle is an end and where there is a beginning. Everything gets tied together, and all the application and prescriptions from one year becomes a layer for the next year's applications. It is all about data and information. Variable rate application, crop scouting, variable rate pesticide application, harvesting with a yield monitor, data analysis, and soil sampling. Conclusion. Precision ag, the practice of managing specific areas within the field. It is all made possible via GPS. It requires data collection and analysis. Applications include yield gathering, navigation, and variable rate application. Variable rate applications can be made in pesticide, fertilizer, seeding, or irrigation. That wraps up the intro chapter. Hopefully you received a little foreground and enough of the finished result to see the route of this journey. One thing mentioned in a little detail that will be gone into fully in the next chapters is GPS. It is what makes all of this possible. The other things mentioned in this chapter that will be covered a lot more in detail in this class will be yield monitoring, soil sampling and analysis, remote sensing, GIS software, and variable rate technologies.